This video will show you how to make a regression line on a TI-nspire calculator. So I've got some data here which came from a textbook, and it's rainfall, and I think it's yield in kilograms of olives for olive trees. What you can see kind of is that if you have the highest amount of rain, the over 20, you get higher amounts of olives, which I guess makes some sense. First thing you want to do is get your data into the calculator. So if you need to, you can pause and look at that. Basically, you add a page here, control page, of Lists and Spreadsheet, because you make a list of this data. And you would type a title for your column, like a rain or something, and then enter each of the values. So if I did rain, and down here, arrow down to 11, enter 10, enter, and so on. And then go to the next column, make another one. I have actually been a little more efficient than that, so nope. I've got these in already. There. So if you need to, again, pause that and put those in. To get a regression, my recommendation is to do it on this page. That's not the only place. I'll show you how to do it with a graph, but I think this is more useful. So with your cursor in the last column that contains data, go to Menu and Statistics, because regressions are statistics, and Calculations, because we want to calculate a regression. And of the many regression choices here, you want the first one, linear regression, mx plus b. It will ask you what your variables are. You can see here rainfall is my explanatory x variable. So if I arrow over, I can choose rainfall. And then tab to the next one and do the same thing and choose yield, which is at the bottom. And the cool part about this is it saves the regression equation. I've actually got something in F1 right now. So it offers to save it to the first function which is not already in use, which in my document is F2. You can give it a name yourself too. Anything that's a valid variable name on this calculator could be used here, but I'll just remember it's F2, that'll be fine. And I'll say okay. And here's the information I needed. There's the slope M, and there's the y-intercept B, and there's the R squared. It shows a little bit more than this if you keep scrolling down, not a whole lot more. So past R squared, we've just got two more rows. One is the R, the correlation coefficient, and the other one is the residuals, which are the difference between the predicted, each of the predicted values and the actual data point that we have. Let me make these together. Here we go. So that right away will give you your equation. You can write it down now. Y equals 1.78. I'm using 3 sig figs, which is the standard thing on IB exams, although certainly you could choose something different. So 1.78 x plus 40.5, and you could do things like interpret this. For every additional centimeter of rainfall, the model predicts 1.78 more kilograms of yield of, I think it's olives, like I said, per tree. This predicts if there is no rain that you get 40.5 kilograms per tree, but that is extrapolation, which is, number one, dangerous because we don't have any data about less than 7 centimeters of rainfall. And number two, if there's no rainfall at all, like trees may actually die, it may really be different than this. We can see the coefficient of determination, which is 0.7276 stuff. That means that 73% of the variation in yield is explained by the variation in rainfall. Obviously, there's other things that go into that. The correlation coefficient, that's R, 0.853 is pretty strong and positive. The more rain, we would expect the better the yield of the trees. The other way you can get this information, or at least get some of this information, is from a graph. The graph absolutely adds something. So control page again, and this time data and statistics. You can see the little picture of a graph there. It gives you one of these. And the explanatory variable, that's generally on the horizontal axis. I mean, always on the horizontal axis. Rainfall. Click over here and add yield to that, which is, I started with a Y and I have to scroll all the way down to get to it. There it is, yield. And you can see it's not all that linear, really. I mean, the calculation that we did said that 0.853, that's a fairly strong linear relationship, and yet this one is messed up. In fact, it looks almost like maybe there's some sort of quadratic relationship, that there's an optimum amount of rain, and after that, the yield falls off. So pretty important that you look at a picture to see what's really going on. But if you want to get the linear regression on this screen, it is Menu and analyze, because we're analyzing the graph by adding a regression. And it's the first one again. And that's the same equation that we already had, 1.78x plus 40.5. You get the r squared value there. That's the same one that was hidden back here someplace. There it is, 0.727. This does not show the correlation coefficient, and people sometimes confuse those. R squared is not the correlation coefficient. It doesn't indicate direction because it's always positive being squared, or always non-negative. But that's also potentially a useful thing to do. One of the advantages of using this version, the spreadsheet version, is that when you go to just a calculator page and the variables menu, you can see that F2 is a function I can access. And then I can say, all right, what if there were 14 centimeters of rain? Then I can put in 14 right there, and it will calculate using that model what the predicted yield is. It also will indicate stupid things. So if I said, what's F2 of 0, there's that 40.5 if there were no rain. What's F2 of 1,000? Well, you get 1,818 kilograms of olives per tree, which is obviously not going to work. So you have to know what's going on, but you can make it calculate some things pretty quickly. I think that's all I was going to put on this video. I hope that's helpful.